Hi dear students, in this video I'm going to explain multiplying the matrices, and for this one we are going to start with the previous video, the details from the previous video. As you see, firstly I'm going to try to explain on that one, then we are going to continue multiplying the matrices here. If you remember, in the previous video we multiply only rows by columns, and the main idea is that one rows multiplying by the columns, so it's going to be in multiplying the matrices. Here we were multiplying only row matrix by the column matrix in the previous video, but this time we are going to change that one also. We are going to multiply whole the table here. And before starting to this one, we have to understand the order should be suitable for that one. This is very important here. Orders must be suitable means here, if you remember, this number, the 3 shows the row number of the, and 2 shows the column number of the matrices. And here, this matrix, the first matrix from this table that we get, it is 3 by 2 matrix. And when you are going to multiply, this is 2 rows and 1 column. It's going to be here. We are going to multiply 2 by 1 matrix, and the result it should be 3 by 1 matrix. And as you see here, it says from the rules also, you can understand from this table here, the second value here, the column number of the first matrix, it should be equal to row number of the, again I'm repeating the sentence, column number of the first matrix, it should be equal to row number of the second matrix. So if they are equal to each other, we can multiply. If they are not equal, we cannot multiply. From the beginning, we should say that these two matrices cannot be multiplied. What should be the resultant matrix? The dimension of this order of the new matrix, it should be 3 times 1 here, as you see, 3 and 1. As you see here, 3 times 1 is a coming, and you know how to calculate. These are 4 times 6 times 400 and 2 times 550. It's going to be, that makes totally 2500, and we are going to calculate. These are now with the new matrices. Okay, now I'm going to continue with the worked example. Here the first matrix, it is equal to 2 by 2 matrix, and the second matrix, it is 2 by 1 matrix. So this number, since they are equal to each other, we are going to multiply them. We may multiply them, and the multiplication result, it should be like this. By the way, the new matrix, the dimensions of the new matrix, it's going to be 2 times 1 matrix. We need to understand also that 1 here is going to be equal to 3 times 7. Here I'm going to write the new matrix, resultant matrix, as a resultant matrix here. 3 times 7, for understanding better, I'm writing all the details here, plus 2 times 5. We don't have another column, so we are going to continue with the second row. 4 times 1, plus 1 times 5, it's going to be 4 times 7, 4 times 7, and 1 times 5 it should be. And the result, it's going to be equal to 3 times 7, it's 21, plus 10, and the second row, 4 times 7, it's 28, and 5 times 1, it should be equal to 5, and the resultant matrix, it is 31 to 33, it should be. Okay, so this matrix also 2 row 1 column matrix it's going to be. Now we are going to do the same operation for this one, and maybe to practice more, that's why I'm doing the same thing. Again, I'm showing here the rows we are going to multiply. Here columns, it should be from the first one you're going to get the rows, and the second one you're going to get the columns. 7 times 0 plus 1 times 3, and 4 times 0 plus 2 times 3 it's going to be, which is equal to 7 plus 0, 7 plus 3, 4 times 0 is 4, and plus 6 it's going to be, which is equal to 10, 2, 10, 2, it's going to be 10. I'm going to rewrite this part. 10, 2, 10 matrix, it should be. This is only coincidence, it is not necessary, but if one of the row is 0, both entry it's going to be 10 and 10, or the same number, it is only coincidence. You need to know also that one. Here, this is 6, by the way. Okay, let's continue with this matrix. Now here, there are 3 rows. This is 3 row times 2 columns matrix, 3 by 2 and 2 by 2. So I'm going to here, firstly, I have to make clear that one. Firstly, I'm going to multiply. This is the important part now. These are equal to each other, so we can multiply. Equal, so we can multiply. We can multiply. Okay, when they are equal, we can multiply. Then I'm finding the here 1 times 5. I'm writing the resultant matrix here, maybe like this. 1 times 9, 5 times 3 plus 5 times 3, 1 times 4 plus 5 times 7 it's going to be. So I finished first row, first column, and then first row, second column. First row, first column, first row, second column, also it's going to be. Then here, second row I have, and second row, first column, which is 8 times 9, plus 2 times 3, and here 8 times 4, plus 2 times 7 it's going to be. Here, as you see, the second number is always same, and here the first numbers from the first row, first column, here it's coming, which is 0 times 9 plus 6 times 3 it's going to be. Then here again the same numbers, 0 times 4 plus 6 times 7 it should be. And I'm going to close this up, then I'm going to do operations one by one. 1 times 9 it's equal to 9 plus 5 times 3 it's equal to 15, and 8 times 9 72, 2 times 3 plus 6, 0 times 9 0 plus 6 times 3 18, 0 plus 18, I'm sorry, and then 1 times 4 4, 5 times 7 35, 8 times 4 32 plus 2 times 7 14, 6 times 4 times 0 0, then 6 times 7 42 it's going to be. And if we finish this part, here the resultant matrix it's going to be equal to, here 9 plus 15, which is equal to 24, and the down it's going to be equal to 78 18, on the other side it is 39 46, 39 46 and 42 it has to be. And this is the last matrix, and as you see, this is 3 by 2 matrix. There are 3 rows and 2 columns here. Okay, now we are going to multiply 2 by 2 matrix by 2 by 3 matrix here, 2 rows and 3 columns, which means these two, they are equal to each other. So the resultant matrix, it's going to be equal to the resultant matrix, it's going to be equal to 2 times 3 matrix. First, we need to know that one. Okay, I'm going to multiply them here. So firstly, 4 times 1, as you see, 4 times 1, and 0 times 3, it's going to be 4 times 1 plus 0 times 3, it's going to come. Then 4 times 0, 4 times 0 plus 0 times 2, and 4 times 2, this is the last one, 4 times 2, and 0 times 5 plus 0 times 5 it's going to be. As I told you before, the second numbers always it's going to be same, and the first numbers, they are going to change with the 1 and 1 here. 1, 4, 0, 4, 0, 4, 0, these are going to change 1 and 1, which means 1 times 1, 1 times 1, 1 times 3, plus 1 times 0 plus, as you see, 1 times 0, 1 times 2, And here 1 times 2 plus 1 times 5 it's going to be. And then if I add them here, 4 plus 0, 0 plus 0, 8 plus 0, 1 times 1 is 1, 1 plus 3, 0 plus 1, 0 plus 2, 2 plus 5 it's going to be, and this is the resultant matrix now, 4, 0, 8, 4, 2, and 7 it's going to be. As you see, this is 2 by 3 matrix it's going to be. Okay, this is the end of the video. We are going to solve the questions together with you in the class.